again. And this is really just an annoying UI decision. Notice on the right-hand side here, if you want to localize a .strings file that I have created myself manually, unfortunately you have to click this big button called localize. And here's where I'll be prompted, oh, do I want to localize this file into which language? Spanish. Now I'll go ahead and localize. And now, that did not behave. Oh, there it is. By default, Xcode does not check both boxes. So if we now check English and now go over here on the left, localizable.strings has both English and Spanish forms. So if we fast forward now to the climax of this example, what we'll see is an example that has both the Spanish version and the English version exactly as follows. In Hola 2, we have supporting files, and if we go to localizable.strings, specifically the English one, notice that, again, this is just a mapping of keys to values. Quote-unquote greeting equals quote-unquote hello world. Notice that it's not an NS string. These are C-style strings now, so there's no @ signs involved in this file, but they do end with a semicolon at the end. If I go to the Spanish version, the key is the same, so you don't localize that, but the value does change. And so because this file is called localizable.strings, iOS will load it automatically for you and use that when you call the function that we did earlier called NSLocalizedString. And there's one last thing I did here in advance. In this file, which to date we have not actually looked at, infoplist.strings, according to the documentation, if you define a key called cfBundleDisplayName, you can also change the name of your application programmatically. So in this case, I want my application to be called Hola, but if the user is English speaking, I want it to be called Hello. So no more Hola 1, Hola 2. This is the formal name for my application. If I go ahead and run this, I'm still in the simulator here. So we should see now the second version of this code. Voila. Hola mundo. And if I now go back to the desktop and take a look at the program's name, it's Hola. If I go back to English, that should change to hello, and the string should go to hello world. So sort of lesson learned here, especially if you're planning on doing something for the App Store and you actually do want to appeal to multiple languages, this is the sort of thing where it's good to start designing your strings files now so that you don't, after writing 2,000 lines of code, have to go back in and start ripping things out and redefining key value pairs. If this isn't a problem, if you have no expectation of localizing, not a big deal, but it is this easy. And it's a lot easier to do at the beginning, even if you just have a localizable.strings with only English, because just think how trivial it is when you make a friend who speaks Spanish and he or she can then translate your whole app for you just by your sending him or her that text file to send back to you to import into the project. Yeah?
Just for example, French, does iOS choose randomly English or Spanish, or is it default first keyword?
Good question. By default, there's still one primary language, and in this case, it's English, because that's what I started with. So what would happen is you would get the English version by default if the user has chosen some language that your app doesn't explicitly support.
So if I can start, for example, with Dutch?
Good question. Most likely, if Mac OS is configured for Dutch, and therefore Xcode is as well, when you download it from the Dutch App Store, I believe that's what will happen. But I've not had occasion to test that. Other questions? All right. So where can we take things from here? So I'd propose that from here, there's a couple of gaps we can fill in before moving on to a climax, albeit a 1980s style climax of a two-dimensional game, but SQLite. Let's add one other tool to your toolkit. What was SQLite all about? OK, good. So it's a flat file relational database. So this is just a fancy way of saying there's no server involved. There's just a big binary file that can sit inside of your application that can create the illusion of a database to your application, namely a SQL database. And a SQL database allows you to do searches and queries along the lines of select and insert and delete and update. And even if you're not familiar with that, those four letters together compose a paradigm called CRUD, C-R-U-D, for create, read, update, delete, which is a very common paradigm for talking to a database, which essentially lets you do anything. You can read from it, you can write to it, you can update things, you can delete things, you can store data in read-write fashion. So why would you care to use SQL and this database language as opposed to just using a plist like we've been using for the second project, or even a .strings file if you just have a list of strings, or some other file format altogether. Speed? In what sense?
It would take a lot more time to have to read and write from files than it would to sort of like make a dictionary or an array and process the data.
For sure. Certainly for large data sets where you have thousands, tens of thousands, hundreds of thousands of records, if you stored it in a plist, well, by default, that's just an XML file. So really, it's just a big, long list. So if you were to do searches on a property list, you essentially devolve into linear search. And then in the worst case, maybe the string you're looking for in the dictionary is at the end of that plist file. So it's going to take you thousands or tens of thousands of reads in order to find the word you're looking for. By contrast, if you use an actual database, whether it's MySQL or Oracle in the real world, or SQLite in a constrained environment like this, you can say something like select the word that starts with Z. So I'm using sort of pseudocode verbally, but you can express yourself more precisely. Select the word that starts with Z. And what SQLite can do for you, if you tell it in advance, is it can give you what are called indexes, essentially tree structures that have been saved to this file that once loaded into memory allow you to search this file much faster than, say, linear search would allow you to do. So at least for large data sets, it allows you to express yourself a little more precisely than just iterating over a big list of things and to get that data more quickly. Unfortunately, for those of you who are familiar with SQL, the price you pay is in sheer complexity of the code, since to date it's still a C library, which is a pain in the neck to use when doing something as simple as we just described. But nonetheless, so that you have this expressive capability at your disposal, particularly for your third project if doing something with a decent-sized data set, let's take a look at this example called SQLite from tonight's code base. App delegate, look special? No, nothing new there. AppDelegate.m, anything going on in here? Nothing there. So hopefully the interesting stuff starts in the nib file. OK, so apparently this app has to do with cities. No, this is just, again, stupid boilerplate appearance of any UI table view controller. So this just means the application has a table view controller. And let's actually spoil the results. Let me go ahead and run this application and see what happens inside of the simulator. And what we can see here in the simulator is that all this application does is it opens the contents of a SQLite database called small.sqlite, as we'll see shortly, and it lists those 5 words from the small plist file that we gave you for the most recent project. So what I did in advance was I wrote a little script that converted that property list file into a binary SQLite file. It's pretty easy to do. And then I included the small.sqlite file inside of the project by just dragging and dropping it from my desktop. So how is this actually behaving in this way? Well, let's take a look at viewcontroller.h. Nothing going on there. So all the logic must be in viewcontroller.m. So first of all, notice that I've declared an NS mutable array as a property called words. And this is just where I'm going to store my words when actually using them, much like you probably have for Evil Hangman after you've loaded the property list. And if I scroll down here, let me get rid of one remnant there, I have init with nib name. And this is where the nightmare begins. So, and I say this because it's just a pain in the neck to actually code SQL queries in this way. But this is the way it is not only in Objective-C, but in some other environments as well to this day. So notice I'm first initializing myself with the nib name, whatever that was, by calling the parent class. Then I'm declaring an NS mutable array here and assigning it to my property. So I just have an empty changeable array. And now, what am I doing in English, or sort of semi-technical English, with this highlighted line? What's apparently going on there, even if you've never used SQLite before? Yeah? Good. So I'm creating a pointer called db to an object of type SQLite, whatever that happens to be. It's some kind of structure, presumably. And then in that next line, notice I'm going back into Objective-C mode. The highlighted line is effectively C. So here I'm declaring a path variable that's the result of looking for the file called small of type SQLite. So this is just a fairly verbose way of saying, give me the path to the file called small.sqlite. And notice over here on the left, that's the file I promised that I dragged and dropped into the project. It's a binary file, so clicking on it won't actually show me the contents. Now here is a bit of syntax we haven't seen too much, but you might recall from Rob's lecture a few weeks back. SQLite 3 underscore open is a C function that opens a database connection. So database, notice that path is of what data type at this point in the story? It's an NS string. But SQLite 3 open, perhaps take my word for it, is a C function that has no concept of Objective-C classes and objects. So we essentially have to convert path from an NS string to what most people call a char star, a raw C-style string, which is just the address of a bunch of characters.